Well, hello, hello. Sorry, I'm a little late. I was distracted. I ain't gonna lie. Hey, hey. All right, how is everyone? All I know is everyone was driving like a maniac. I just had to do a couple errands for myself, and I think everybody was losing their damn minds. But, you know, everybody in love with their boo. Out at TGI Fridays near the mall. You know, people going on their first dates. Why do you use Valentine's Day as your first date? I don't really know. But anyway, we're here, and I'm so glad that you are here. So let's do a little bit more math. Let me see if I can zoom in just a little bit. So last time, hello everyone. Last time we were working on multiplying fractions. So now we're going to kind of take a little deep dive on dividing. So before we go into dividing those polynomials, I said fractions, I mean polynomials. So before we start going a deep dive on those polynomials, I want to do a quick refresher on how to do long division. Now, since we all have calculators, when was the last time you actually did long division by hand? Say never, okay? All right. So we're going to kind of walk you through the steps of how to do that. I figured I should do this on a separate sheet of paper so I'm not taking up the whole entire thing. So I have 6,584, and I'm going to divide that by 28. Of course, I'm not going to use simple numbers. What? What? Make it easy? Are you kidding me? I have no idea. So this is my dividend. This is my divisor. So if I'm doing my long division sign, which you're probably like, ooh, I haven't seen one of those in a minute. So what goes underneath that long division sign is my 6,584. What goes out as my divisor is the 28. And the answer that we're going to get that's going to be up top here, that's my quotient. Hello, everyone. I'm going to try to say hi, 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 hi. All right. So first thing that we need to do, so before we even get all kinds of crazy, we go to the first term. So we have a 6, so it's the first digit. So how many groups of 28 can go into 6? None, right? Hey, Aaron. So 28, no groups of 28 can go into 6. So some people like to put a 0 up top here. It's just not necessary, all right? It's really not necessary. So instead of looking at 6, let's look at 65. All right, that sounds a little more promising. So we want to know how many groups of 28 can go into 65 without going over. All right, so we need to kind of look at our 28 times table. So I'm going to go first with 28 times 2. So I'm going to try to slide this over so you can kind of see what's going on over here. So I have my 16, carry the 1. I have 56. All right, so 56 sounds a little promising. Because if I do 28 times 3, that brings my 4, carry my 2. So then I would have 3 times 2 gives me 6. 6 plus 2, that gives me 84. Way too much, okay? Way, way too much. So we always want to, when you go with the long division, you want to get to a number, okay, that will get us close to this without getting over. So if we're doing the dividend or divisor of 28, so that means 2. So notice I'm not putting the 2 over the 6 because we're not saying that the 2 is going to go into 6. It's going into 65. So you always want to put it over like the ones of the number. write down my 56. Now we want to subtract. Okay, so you always want to do some subtraction. So I can't subtract 5 minus 6. Can't do it. So I need to borrow from the 6. So now that's a 5. And instead of a 5, it's now a 15. So 15 minus 6, that will give me 9. And then what happens, this 8 comes down. Okay, so you get your multiplication, then you write your answer underneath, then you subtract, then you bring down, then we start the process all over again. Okay, hey Chad, how you doing? All right, so we are following in these steps, step by step. Oh baby, gonna get to you, girl. Sorry. Just the songs of the 90s just kind of stick to you, you know? All right. So now we need to do this process over again. So how many groups of 28 can get us close to 98? All right. So if you recall, slide over. We tried the 2. We tried the 3. 3 gave us 84. Now, I know if I tried to do it by 4, it's definitely going to be a hell of a lot bigger than 84, and it's going to be a lot larger than 98. So let's put that 3 down. So 3 goes in my quotient, the 84 goes underneath, and we're always subtracting. Okay? Just as we're going through this, you're probably like, oh, this is easy. I've done this before, blase, blase. But think about the process, because we're going to do the same process, but when we're dividing polynomials. So now, 98 minus 84. Okay, we don't have to borrow from the 8. So 8 minus 4 gives me 4. 9 minus 8 gives me 1. Then we bring down the next digit, which gives me 4. Okay? So now we need to think, how many groups of 28 can go into 144? Well, we already know that 28 times 3 gives me 84. So let's see. Well, it's 28 times 4. So we have our 32. So the 2 goes down, 3 goes over top. 2 times 4 gives me 8, plus 3 gives me 11. So let's see if we can go a little bit higher. It's a contender. So now we're going to try 28 times 5. So 8 times 5 gives me 40, so that's a 0, carry the 4. 2 times 5 gives me 10, plus 4 gives me 14, so 140. Ooh, that looks like it. This long division is time consuming. Yes, it is. It is. Wait till you see when the variables get in there, all right? So 5 goes over top. Then we bring down our 140. We're going to subtract. 144 minus 140 gives me 4. And there's nothing else to bring down. Okay, so since there's nothing else to bring down, we have this 4 that's kind of left over. This is our remainder. And when you have a remainder, the way that you generally write a remainder, back in the day, you used to use like a capital R and you put like the 4 next to it. Remember those days? Yeah, that was the good old days. But now, what you're doing is you're taking this 4 and you're adding it to the 4 over top of the divisor, which is 28. This is how you get your cents. This is how you get your change. Okay? So 4 over 28, that could be reduced to 1/7. So if I wanted to, keeping it as fractions, trust me, there's a method to this madness, okay? So keeping it as a fraction, our answer, I'm going to put it inside of a box over here, is 235, and we're adding on that 1/7, okay? So if you wanted to figure out as a donut, oh, thank you so much for the gifts. My niece needs to be here. Well, get your niece. Oh, she's probably out at, TGI Fridays. Hell, these kids are getting expensive nowadays. These kids are like taking their dates for the first time to like Ruth Chris and stuff. And I remember Ruth Chris was like the place. Okay? They're not doing McDonald's dates anymore. They're just getting all fancy and stuff. I'm like, well, who's money? But we'll talk about that later. Right? Okay? This is long division. Okay, so I had to kind of bring it back. And yes, is it tedious? Yes. Is it annoying after a while? Yes. But these are the steps that we have to take in order to carry it over into division. All right, so let's rip off this Band-Aid and let's try to go into dividing. Okay, long division. So right now, anytime we're about to go into some new venture or into something that we don't normally do each and every time, we always take a breath, let it out. This is a safe space. We're going into a new venture. It's gonna be okay. All right? Remember, there's no test here. All right? This is not a life and death situation. We are not playing Squid Games. It's gonna be okay. All right? So if you're all right, go ahead and tap the screen. Let me know when you're ready. And then I'm gonna jump right into our very first problem. Okay? So it's gonna be some steps. If you feel lost, please do not hesitate. I can see the chat off of my computer. So please don't hesitate like, okay, Audrey, I'm lost, because I'm going to take it step by step. If there's going to be some people here that's like, oh, I know this, I can do this, boom, 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 boom. Awesome. I love that. But I'm also going to cater to those that are just like, I haven't seen this since I was a fetus. Hell, even let's go back further, since I was a zygote. Some part of the metamorphosis phase, okay? So it's going to take me some time, and I got you. Thank you so much for sharing the lives. If you know of anyone that needs this, please bring them on in. All right. What about factoring? Isn't factoring a part of this? In a way, it is. But we haven't gotten into the full flow of factoring yet. In a way, we kind of dabbled with it when we did the multiplying of polynomials last night. Okay, so I just want to kind of get into that. All right, so let's start off. So this is my dividend. So I'm doing long division. So here is my division sign. My dividend, which goes underneath, is x squared minus 2x minus 3. My divisor is the x minus 3. Okay? So it's almost like the example that we had. Let me bring that back here. So my dividend was the number that was on top here. That was my dividend. My divisor was the denominator. All right. So now we have to think. How many groups of x's goes into x squared? So some people like to, dude, where were you when I was in school? We were probably in the same class. So combining like terms, true. But first we have to get what's going to go up first. So some people like to think it one of two ways. You can either, when you divide, like when we multiplied, we add exponents. Now we're dividing. So if I look at it like this, x squared divided by x, I have two x's up top here. I have 1x in the bottom. When I'm dividing, I'm canceling out. So 1x up top, 1x down the bottom can be grouped together and canceled out. So I'm actually have 1x left. The shortest way to think of this is when you're dividing, you're actually subtracting the exponents. Okay, subtract exponents. Yes, Rachel, thank you. I have a test soon. Not a problem. All right, so pokeballs, yes, x. So if you think of that, if I take my first number, my first term, and I subtract or basically divide by the first term of this, I'm really subtracting the exponents. So I get an x. Now, here's the thing. You do not line up the x with an x squared. You line up the x with the x's. So I'm going to put the x over top here. I'm going to pause. Talk to me. How are we doing? If I'm going too fast, too slow, talk to me. Because I want to make sure we're all on the same path. Okay, got a lot of people following me, which I love it. Thank you so much. All right, I'm seeing some hearts. It's a little sporadic. So I'm like, people are like, I don't know what's going on. But if you don't know what's going on, okay, I'm tracking. Why don't you put the x over the exponent? Perfect. We're playing the matching game. Okay, we always want the x's aligned with the x's, the x squareds aligned with the x squares, and the constants aligned with the constant. Okay, we always want to keep everything very uniformed. If not, it gets crazy when you get into some more technical stuff. All right, so good question. Thank you, Dylan. If I wouldn't have had you as a teacher, I wouldn't have failed algebra. Oh, thanks. Okay, what if there's no x with the second number? So what if there is no x with the second number? So that means you were going with the constant, then you line it over top of the constant. I'm going to be truthful. Majority of the time, there's always going to be at least one x involved. That's just truthful. All right, good questions, guys. I love it. All right, so we figured out what my first term is going to be in my quotient. Now, we're going to use that x to figure out what's going to go underneath the dividend. So let's use it. So x times x gives me that original x squared. So now I'm going to use this x again. But this time, I'm going to multiply it with the negative 3. So x times negative 3 gives me negative 3x. And I'm going to stop right here and see how you're doing. Okay, a lot of follows. Thank you so much for the follows and the taps and the likes. I'm loving it. Okay, questions. Please do not hesitate. Put it in there. Okay. Yep, and share it with your family, friends. Why not? We're here on a Friday night doing what? Math. This is awesome. I was like, are you subtracting that? Yes, Rachel, we are. Okay, put in parentheses and distribute the subtraction. Then switch the signs, add and subtract. Okay, so here we go. So everyone's ready for the next step. So once we figure out we have two terms out here, so there should be two terms down here, which they are. And we're always going to subtract. I like to circle it because it reminds me that I'm subtracting. Your first terms, here's a small hint. They always cancel out. If they don't cancel out, that means something's up with the signs. So now, ready? -2 minus -3. Ooh, we're being a little fancy. So here we go. I'm going to write it out. -2 minus -3. What do we get for a solution for that? Okay, Rachel's saying 1. Thank you for the follows. Can't you use synthetic? We can, but here's the thing. I need to show you both. Okay? Good eye. Trust me, something like this, I sure as heck will be using synthetic. But I have to show both. I want to show both. Because there's going to be some people that's going to be taking classes that their teachers are going to want them to do long division and the synthetic. So I want to show both. So when they go into those classes, they're not completely lost. They can say, oh, wait, I've seen this before. I can catch it and catch it early. Okay, so I wouldn't use either. Okay, so I wouldn't use either, zone or friends. Okay, so this is factorable. Yes, it is. All right, so we do have a 1 because when you minus a negative, remember it turns positive. So -1 plus 3, that gives me 1x. So now we have our 1x. Just like what we did with the other long division, after we subtract, we brought the next term down. So that's what we're going to do now. We're going to bring down the -3. So now we need to figure out, okay, what times x gives me 1x? We can do it that way. That's going to be a +1. So we're repeating the process again. Don't you switch the signs on the -3x as you do with the x squared? We did, because a negative times a negative will give us our positive, Alex. Okay, so we did switch the sign. So that's how we got -2 plus 3x. So it gives us our 1x. Okay, so yes. So 1 times x gives me 1x. Then we use the 1 multiplied to the -3 gives me -3. Again, we're going to subtract. So 1 minus 1, they cancel out. -3 minus -3, that's the same as saying -3 plus 3. So that gives me a 0. So we don't have a remainder. Okay, I like how you show the process with long division. Thank you. I'm teaching this lesson next week. Oh, nice. I swear this algorithm is better than I thought. I know, we all sneak in here. See, all I had to do was just get out of my way and just go ahead and do the lives. Like I was for the longest time not doing lives. I just started doing lives last week. So it was God. It's God putting us together. All right. Where was this before my math quiz Thursday? Oh, I'm sorry. See, I should have came on earlier. That looks more normal. Yes. Okay. And I just followed. Yay. All right. So now when they say, when you divide those two and what's my answer, your answer is up here. That's the quotient. So your answer is going to be x plus 1. I think someone had that up way ahead of time. I would scroll to find out, but I might lose something. Knowing me, I might touch something and something will just explode. Okay. All right. So we're basically doing it step by step. Now, let's see if we can try another one. And this is just, I just want to stick with as many monomials as possible. I want to keep it as simple as possible. All right, so let's go over here. Example number 2. So we have we have let me try this one. So I have x cubed. I'm going to write it up here. X cubed minus 2 divide by x minus 1. There is always one of these fun little problems. And sometimes you think that your teacher is just trying to be cute. And sometimes they act that way, okay? So, walking you through this step by step. So, underneath the division symbol, we have our x cubed. But notice, my degrees, remember what the degrees were? The degrees is your exponents. All your degrees need to be represented. If you notice, there isn't an x squared, there isn't an x, it just went from x cubed to the constant of -2. So just followed, I've always just used factoring and avoid synthetic division. Okay. I was like, I'm going to start following you, watching your lives with my son. He's about to be in 6th grade. Lovely. Okay. Algebra 2, most likely. Yes. When we go into the division, usually you see the long division in Algebra 2. Some, if they're taking an honors class, some of your honors students for Algebra 1 would see the long division. But mostly everyone from Algebra 1 generally sees adding and subtracting and multiplying polynomials. All right. So, students are great. Yes. Just list again. Okay. So, since we're missing the x squared and we're missing the x, we need to put a placeholder underneath here. And this is the part that gets a lot of students. They're thinking, oh, okay, x cubed, I can just put the x minus 1 out here. Okay, I know I got an x squared. All right, and I'm done. No, you have to put placeholders. So right here, I'm going to put 0 x squared because my x squared needs to be represented. 0 x because my x needs to be represented. And then the constant, which is a -2. So all your degrees in descending order has to be represented. If I may, I think I can. I might have to slide down just a little bit. If you look at the first equation that we did, we have x squared, we have x to the first power, or just x, and we had a constant. So all my degrees were being represented in descending order. But for this one, not all of the degrees are being represented, okay? Taking this long division is so confusing. It is, Des, and we're going to walk you through step by step. So Des, if you ever have a question, please do not hesitate to put it in, and anybody, put it into the comments, okay? Because I can see the comments. It's flashing, but I can still see it. So now, since all of my degrees are being represented, why x to the 0? Because we need to the first power, all right? We need to the third, we need to the second, we need to the first, and then the constant. Okay, so all of it from descending order, 3, 2, 1, 0. Okay, that's basically what we're looking at. Has to be represented. So now we're going to start the process. We're okay? So, what times x gives me x cubed? I have a -1. I have a 1x. X squared? Yes. Okay, x squared, x squared, x squared. Good. Now, since it's x squared, we line the x squares with the x squared. Don't put it underneath the x cubed. Gotta line up like with like. So this is x squared. All right, are we okay? How we found that? Questions on that? Okay. I was like, if you don't, you're only dividing the negative 2 by x. Right, so we need to have them all represented. So now, we got this x squared. Multiplied by x gives us our original x cubed. Now we're going to use the x squared multiplied by the negative 1. Okay, so that means we're using this quotient to multiply to both terms in the divisor. So that gives me a negative 1x squared. Okay, how did you find it? So how did I find the x squared? I had to ask myself, so what times x will give me x cubed? If we remember or if we recall about exponents, when you multiply, you add the exponents. So it's almost like, okay, there's 2 x's here. There's 1x. If you don't see a number in the exponent, it's assumed to be a 1. So what plus 1 will give me 3? It will be 2. That's how we got the x squared. Okay, group the problems with parentheses is what I'm saying. Okay, cube has 6 sides. Y is x cubed. Call a cube. So we're looking at the 3 dimension, John. Okay, we're looking at the 3 dimensions. So when dividing, we subtract exponents. Correct. Okay, when you're dividing, you subtract the exponents. All right. So I know synthetic division is my favorite, but a lot of people, a lot of teachers are still teaching long division. So I want to get people to get exposed to this, okay? So x cubed cancels out because we are subtracting. So now we have 0 minus a negative 1. What would I get for a result? Okay, 0 minus a negative 1. What would I get for a result for my x squares? Okay, we got Miss Wall with x squared. We got Janae with 1. Do you teach bottom up? We got 1. We got 1x. We got, is that a positive 1 or a negative 1, Mr. B? And Fancy Pants, is that a positive 1 or a negative 1? Soda Pop, same thing. Okay, make sure that it is a positive 1 because a negative and a negative makes a positive. All right. So we all know that 2 negatives, they always say 2 negatives make a positive. Unless they're human beings, they'll put us in jail. So, so that means we have a 1x squared. And that we solved, that means we bring down the next number, plus 0x. So I'm going to change pens so we can kind of see the motion a little bit. So now we're going to do the process again. So what times x gives me 1x squared? 2 negatives don't make a right. I know, right? Okay, why not the whole equation? What do you mean, why not the whole equation, Mrs. Wall? I think I probably missed the whole thing. Okay, you may decide to teach us next week. Thank you. Not a problem. Why doesn't the x squareds cancel out? Well, it can't cancel out because the the coefficients are not the same. Whereas here, the coefficients were both 1s. So 1 minus 1 gives me 0. Here, we have 0 minus a negative 1. Okay, so 1, okay, not a problem. Probably break everything down. Thank you. All right. I need this kind of math in my daily life. I know. But believe it or not, you are using a form of this in your daily life. It's just because it's not set in this, but even with your calculations of you figuring out, okay, I need to get to a friend's house, I need to get to an appointment, I'm going to have to deal with traffic. Usually it takes me 10 minutes, but if I'm going to be dealing with afternoon traffic, I know it's going to take me at most 25 minutes. So if I leave at this time, all that logic, you just did long division. You did the breakdown. You took the difference. You did long division. Just because it's not written out in this form doesn't mean that you don't do it. I know, it's crazy. All right, so we have our plus x, because x times x gives me this x squared, or 1x squared. Then we multiply the x with the negative 1. That gives me a negative 1x. And what we're going to do is subtract those two lines. Remember, 1x squared and x squared means exactly the same thing. All right, so don't be like, oh, that's different. No, it's exactly the same thing. Okay, when you bring down the next equation, why is not the whole equation? Because your divisor only has two terms, Mrs. Wall. Okay, so if your divisor only has two terms, that means you should have two terms before you start doing your next line of calculation. Okay, because if you bring the whole thing down, it gets confusing. And then you just have this kind of hanging around and you're like, let me just combine it. Because that's how our brain kind of works. Okay, awesome. All right, so that means 1x squared minus x squared cancels out. 0 minus a negative 1, that's a plus 1. So we got 1x again. And then what happens? Let's bring down that next term. And that next term was a minus 2. So the torture is almost over. All right, so we got to do it one more time. All right, so what times x gives me 1x. What should go up here with everything? Put it in the chat. Not a problem. Okay, nice. We got a 1. We got Mr. B with a 1. Okay, perfection. Get rid of the question sign because you're right. All right, so we got plus 1. Because 1 times x gives me my 1x. And then 1 times negative 1 gives me negative 1. So if I subtract the 2, what do I get for a result? Okay, Mrs. Wall saying negative 1. Okay, and when he's saying negative 3, I'm seeing a 1. I'm seeing 1 and negative 3, or 1. Okay, don't be intimidated by other people's answers. No, sorry. Okay, all right. Not a problem. We got 1s, negative 3s, negative 1s, 1s, negative 3s. I feel like I'm doing a binary code right now. As long as there's no zeros, we're good. All right, so negative 1s and negative 3s. So let's take a look. So we have a negative 2. See if I can raise it up a little bit. We have a negative 2 minus a negative 1. So if I have a negative 2 minus a negative 1, that's the same as saying, see if it's in the shot, when you minus a negative, remember they turn positive, because a negative times a negative gives me a positive. So this is actually negative 2 plus 1. So negative 2 plus 1, the answer should be a negative 1. All right, awesome. Okay, I have to imagine a number line. Yes. Or think of it this way, Mrs. Wall. You owe me $2. You gave me $1. You still owe me $1. Okay? So I know. If you think of it as money, we know money. See, gotta stick to my instinct. Exactly. Do not succumb to peer pressure. But that's what it is. You know, that's what it is, right? All right, I know. See, Mrs. Wall, you weren't by yourself. Okay, so that's the thing. But we have nothing else to bring down. So what is this -1? That's my what? What is the name for this -1? Begin. There we go. I try. Oh, as I'm shaking my phone. All right. The remainder, the R, the remainder. You're a good teacher. I try. That's Pyro. Yes, the remainder. Good. The remainder. The reminder, which is the remainder. Got you. Trust me. I was like, I wish you were my teacher in school. Aw. So this was your remainder. Now, this is what makes things different. We are not using that capital R. Okay, that was elementary. Now we're looking at algebra. So when we're looking at algebra, we add on the remainder to our quotient. So that means we're going to have a plus sign. The remainder was a -1, and it's over the divisor. Okay, that divisor of x minus 1. This is your appropriate final answer. So this kind of reminds me of like when we're writing checks, which I know people don't write checks anymore. But if you notice on the end of the check, after you write out in verbiage how much the price of the check is, then it has this fraction of something over 100. It's the change, right? That's what this reminds me for the remainder. The remainder, your change is basically the remainder of the bills. It's what's left over. All right. So that's why they put it as a fraction at the end. Okay. I know. Mind blown, right? Yeah. It's like your decimal. Exactly. But when it comes to polynomials, it's going to be hard for you to write it as a decimal. So they just basically leave it as a fraction. That's why when you start getting into more advanced math, you'll see more and more fractions, and they want you to kind of keep it as its original state, because when you round a fraction to a decimal, you're taking some of the value away from that fraction. So that's why a lot of teachers generally push fractions, because you're giving its true value. All right. So this is why they do these things. So it's always nice. So as a CR person, we still write checks. Yes. Okay. So some people still write checks. What grade in high school do they do this? So this is basically like Algebra 2. And some advanced Algebra 1 students. All right. Do I teach calculus? No, I don't, but I got a guy. So if you're in calculus, just let me know. Just send me a message and we'll chit chat, and I will give you my people's names. All right. 10th and up probably. I hate to use it by grades, because some districts will do Algebra 1 in 8th grade, and then Algebra 2 in 9th grade. Some people will do Algebra 1 in 9th grade, Algebra 2 by 11th grade. So it all depends on how the curriculum is laid out per district. So it's crazy. You should try it, because like for me tutoring, I will see kids about what, oh, I'm taking Algebra 2. All right. Oh, yeah, I'm in the 7th grade. What? How? What? Why? So it's all kinds of crazy. I'll be in Algebra 2 and pre-calculus. All right, cool. My son is doing Algebra 2. Good. Okay. If they need help, let me know, because Algebra 2 is my jam. You can use synthetic for this, though. Yes, you can. But as I mentioned earlier, there are people that are currently taking classes and their teachers want them to do long division and synthetic. So I just want to teach both. So that's why tonight is about teaching long division as well as synthetic. Okay. So I like to show both. Of course, everyone loves synthetic. It's always my fave. Math, how it's taught now is not how I was taught. Exactly. It's all kinds of crazy. Trigonometry in ninth grade. Yep. I have a couple kids that are taking trig in ninth grade. Yep. They are in Washington State, if I'm not mistaken. Wait, yes. And a couple in Alaska. Oh, I never heard of synthetic division. That's crazy. Oh, well, we're about to get into it. Okay. Nice. You can't always use synthetic division, though. Exactly. So that's why we're getting into it. All right. So there's going to be one more that I want to do. And I just want you to I want to ease into it. I'm always like, I just want to ease into it. So let me raise this up just a hair. Never heard of synthetic. Yep, I'm going to show you. So if we have, I'm not going to skip this time because I want to really kind of get to it. So if we have, where is it? Yeah, I don't want that one. I will go with this one. All right, so we have, okay, underneath we're going to have, well, as my divisor, I'm going to have 3x plus 2. Then I have 12x squared plus 17x minus 5. And you're probably like, oh, dear God, Audrey, what are you doing? It's okay. Synthetic equals fake. I know. My son is here, y'all. He's in the 10th grade Algebra 2. Hi, son. Welcome in. All right. So, dealing with the long division. The same exact steps that we took in the previous, we're going to apply here. But if I may do a comparison, what's different? What do you notice is different? Okay, what's different? Especially with the divisors. What's different? Look at the tips of my fingers. Okay, I'm lost. That's okay. Only one square value. 3x, we have a 3x. There's a plus, we got a 3x, we got adding and subtracting. Okay, so yes, the signs are different, but then look at the coefficient of your x's. This one has a coefficient of 1, whereas this one has a coefficient of 3. But you're doing the same process. All right, so let's kind of breathe and walk our way through it. So we have to think of the first two terms. What times 3x will give me 12x squared? So we're not canceling anything out right now. First step, what times 3x gives me 12x squared? Okay, we got Mr. B, we got V, they're both saying 4x. Hello, Dr. Boots. Okay, Mass Pyro saying 4x. Okay, we have a 16, we have a 4x, we have a 4x. Let's see, one more person, let's see. All hearts joining, thank you. Okay, nothing. So we got 4x squared, and we got 4x, okay? So pause. So what times 3 gives me 12? That gives me a 4. So what times x gives me x squared? That's an x. So we're going to have a 4x. And we always line the x's with x's. Okay? Can everyone see the screen okay? I'm kind of losing sight here. Okay. Now, not x squared. No, because x times x gives me the x squared. Because when you multiply, you add the exponents. Okay. I got it right. Good. All right. So, we're okay. So now, we're going to use this number 4x. And we're going to multiply each of the terms of the divisor. So let's start with the 3x, which we already know is going to be 12x squared. Why wouldn't 12x squared be 24? Because we're not multiplying the 12 times the 2. We're never multiplying the dividend with the divisor. We're trying to find a quotient, a number up here, multiplied by this to give me the quotient. Okay, so you're overthinking. Okay, I'll do it like this. How cool. Okay. Are we okay? Soda pop, Curtis? We're okay? So we're using that. 4x times 3x gives me 12x squared. Now we're going to use that 4x again, multiply it by 2. So 4x times 2, that gives me plus 8x. Okay. So now we're going to subtract. Okay. Good. We do have our 8x. I think a lot of people did, Jordan, back then in high school. Okay. It's always going to be how many times can the divisor be multiplied, the dividend right? Correct. Okay. So that means our 12s, they're going to cancel out because 12 minus 12 is gone, including the x squares. Now 17 minus 8. So a lot of people are telling me it's 9x, which is correct. Okay, good. And just like Scoopa says, we're going to bring down the next term. Okay, so what times what gives me this? Use it again to put the answer underneath the next term. You subtract. Once you subtract, bring down the next term. That's all right. King Cash, don't beat yourself up. Again, we're not stressing. All right? We're just kind of walking through the motion of it, and we're going with the flow. All right? So please, give yourself some kindness. All right? The confidence of doing math and pen. I know, right? I'm living on the edge, girl. It's Friday night. How do I celebrate? Let's do math and pen. Okay? Never liked math. And here's the thing. Because you probably didn't have someone that broke it down. You probably just had someone that says, memorize this, memorize your multiplication table. Oh, you didn't get that right. You're stupid. Oh, you didn't get that right. Oh, I don't know why you're in my class. I've had teachers like that I had to curse out multiple times when I was in the classroom. Multiple. Never in front of the kids. I'm not that bold. But I've actually had some teachers that literally was like, these kids are stupid. And I'm like, correction. All right. I need for you to correct that and correct that real quick. Yes, you do not want the wrath of Audrey. It's not fun. All right. Didn't get good until 9th grade. Yep, I didn't really understand math until I was 25. Long story right there. So now, let's think. Let me switch pens. So what times 3x gives me 9x? Okay. So what times 3x gives me 9x? I got a 3, got a 3, got 3, got 3s. Look at y'all. So proud. So I got my positive 3's. So 3 times 3x gives me 9x. So I repeat that 9x again. Now I'm going to use that 3 again to multiply by 2. So 3 times 2, that gives me a positive 6. How are we doing? I'm going to stop right here. All right. I don't understand algebra until after I learned calculus. True. Some people, it does take all the way up to there. It does. I hate to say it. Sometimes it does. All right. So now we're going to subtract those. What do I get as an answer? The x is confusing for me, so when I eliminate it, it's better for me. Okay. I was like, do you minus if it would be 9x plus 5? Yes, because you're always going to subtract. That's how we always do long division. You're always going to be subtracting on that line. All right, so I got a negative 1, 1, 1, negative 11, 1x. Okay, I have 1/3 x plus 2. Where's the 1/3 x coming from, King Cash? So we got 1, we got negative 11, got 1, negative 11, negative 11. Ooh, let's see. I'm seeing like there's a battle. I feel like one of those battle people that come on here and just say, what's the answer when you're doing the order of operation? So right here we have negative 5 minus 6. Okay, negative 5 minus 6. So you owe me $5. For some reason, I loaned you $6 more. How much do you owe me? Okay, not a problem. Okay, so a negative plus a negative is always negative. Yes, if you remember, if the signs are the same, you keep the sign, but add the numbers. So this minus sign can act as a negative symbol. All right, so when it acts as a negative symbol, so that means that 6 right here is actually a negative 6. So when you minus a negative, not minusing a negative, when you have a negative and a negative, you're going to add the numbers. If you want to see it a different way, it's really going to be 5 plus a negative 6. If I want to do KFC, keep, flip, change. Okay? Too many negative, I know, right? Too much negativity. We need that positivity, right? Forgot we were subtracting. Not a problem, Sam. Good. All right. I owe you $14 because of interest. I love it. But for right now, let's not worry about the interest. So we actually have a negative 11 as your remainder. So if I am to put this, KFC, yes, keep, flip, change, or Kentucky Fried Chicken, okay? I bet you as soon as you drive around tomorrow, or maybe even if you were here yesterday, you're probably like, you can't unsee it now. So every time you see KFC, you're going to be like, keep, flip, change. It's going to happen. And you're going to be like, ah, oh, Audrey, rats. So now this negative 11, since we don't have anything else to bring down, this is going to be my remainder. So can we do another one? We are going to do another one. And then I'm going to show you synthetic, and then we're going to wrap up for tonight. Okay? Because after you see synthetic, you're going to be like, why don't we just do this? Because trust me, all my students say that. So if we, $14 will get me 2 famous bowls. Trust. So remember, we're always going to add our remainder to our quotient. So it's going to be your negative 11 over your divisor, which is 3x plus 2. Now, Would it be wrong if you said 4x plus 3 minus 11 over 3x plus 2? No, you would not. Okay, that's also a possible answer as well. Okay, but since we're so used to adding on the remainder, you can set it up just like this. Okay. All right. So I'm going to move it on to the other side, but we're still going to be doing division. Let's see. I want to do something that I can actually carry it over and show it to you using synthetic as well. Okay. So while I'm setting up, if you want, if you can tap the screen, that would be amazeballs. All right, thank you. I don't understand at first. I was struggling, but after seeing this, I understand. Awesome, I love that. Okay, I understand now. Yay! See, small steps. Don't have any stress. Don't have to worry about, okay, what's happening next class? Okay, I got a test next class. Oh, okay, my boyfriend is doing what? My girlfriend is doing what? You know, my parents are doing what? Trust me, kids, no matter how old they are, teenagers always has so many things to think about. They have so many layers, okay? I feel a little better. Yes, that's all I want. As long as you feel a little bit better, I am perfectly fine with that. Let's see. I have a whole plethora of different problems up here. Where was that one problem that I just saw? That I was like, yeah, that's the one I want. Oh, where is it? Oh, here it is. Okay, so we are going to do another long division, but then I'm going to show you the same problem as synthetic. So we have our x cubed minus 2x squared plus 4x minus 8. And that's going to be divided by x minus 2. Okay, make sure it's all in the frame. Can you work a completing the square problem? I could, but not tonight. Okay, I could. Will this be on the SAT? Sometimes they put a division problem on there, sometimes they don't. So sometimes the long division one will actually be used as a synthetic one. So SAT ones, usually they use the synthetic version. Because remember, it's a time test and they know that some kids will take forever to do the long division one, so they can't make it as complex as they want to. So they try to keep it to each of the problems will take them about like a minute 30 to complete. Okay. And the best thing about SATs that's going to help you is do the order of process of elimination. Okay. When you're looking at, you're really not worrying about solving the problems, as though looking at the answers and seeing which ones you can eliminate. That's how you do well with the SATs. I hate to tell you, it's just a matter of, do you understand some of the process? That's what they're looking for. Yeah, it's not so much you like, oh, okay, now I know how to solve it. No, they don't care about to solve it. Do you know what the answer is? Circle it, move on. All right. Can you teach the box method? Actually, that's what I did last night. Oh my goodness. I'm going to see if I can release one of my videos, because I'm doing videos on my YouTube channel, which is under ACG Math Tutoring. So I do release some of the videos on there. I'm actually going to be working on that video tonight. So just be on the lookout for that. Okay. All right. And then factoring is actually going to be next week. I'm going to be doing lots of factoring, especially this time period. All right. So as I'm chitting and chatting, Do you guys want to work this out by yourselves? And then we check answers at the end? Oh, trust me. I love how you say, oh, to be smart like me. Trust me, this is years of hard work. I used to suck at math. I don't even know how I became a math teacher. I guess that was God's divine plan. Because early on in my life, throw a fraction my way? Nope. Word problems? Hell no. Not doing that. Okay, you need a model? Okay, so if we all have this copied, if we have all this copied, I can flip over to the other side so you can see. Okay, haven't seen this since pre-calculus in high school. That was 7 years ago. Ooh, James, really? Baby, I'm 52 years old. You weren't even a thought. No, I'm just kidding. When I was in high school. Oh, what does this create? Okay. I did this 3 months ago. Okay, girl. Use that long division, gang. All right. So, if you want to take a quick, let's see if I can take a snapshot. If you could take a quick, grab the screen, click it, A, not Q, A, not Q. So I still have like 4 years until I learn this. All right, not a problem. Trust me, it's coming. Sorry, no worries. All right, so if you already have like a screenshot of this, so you can have it as a reference. And then I'm gonna flip it over so we can get the original problem. All right. What? I'm a senior in high school and I haven't learned this. What? Well, welcome to the world. Trust me, you're gonna learn it. What class? Okay, I'm just doing basic algebra. Okay, so you're a senior in high school. You haven't learned this yet. Trust me, it's coming. It's coming. So most of my kids that are seniors that haven't done all of the polynomials, you're going to see it third quarter. So it's coming. This never helped me besides the tape measure. Yes. But see, here's my thing. I'm so glad that you know how to read a tape measure because the struggle is real, boo-boo. The struggle is real. Algebra 2 and integrated 3. Okay. Yep. So for Algebra 2, yep, you're going to see this in third quarter. So it's coming soon. If it's not going to happen, it'll probably happen before spring break. Yep. It's probably going to happen before your spring break. I've been trying to learn this. Yes. Do you have a schedule of what you work? What do you mean? What I tutor? Touring with T? What do you mean? Like, what's my schedule like for the week? Because I did create or on randomly selected. I was gonna start with randomly selected, and then all of a sudden I noticed because I come on in the mornings and in the evenings. So in the mornings, I'm doing something different than the evenings because I do have people that come to both because they feel like it. And then what's happening, eventually they're going to switch off. So I actually did sit down today to write out a flow of how things are going to go. So like I said, next week I'm going to be doing factoring. So factoring with the GCF, AC method, grouping, solving using the square roots. So a lot of that's going to be for next week. So if I can, I think sometime this weekend I can like type it all up and put it as a post so people can have it, if that will be helpful for everyone. Okay, I'm still in middle school, 7th grade. Algebra 1 is the topic I'm doing right now for high school credit. Good, congrats. All right, so are we ready? ready to kind of like throw in there. And then we're going to do synthetic division. So what time? TikTok doesn't tell us when you're live. I go live Monday through Fridays at 1 p.m. Eastern Standard Time. And then now I have to do Monday through Thursdays because my 8:30 canceled tonight. So that's why I'm here tonight. But Monday through Thursdays at 8:30 p.m. Okay. No, wait. All right, let's go. So let's see how we did. So what times x gives me x cubed? That would be an x squared. Then I use the x squared times the -2, and that gives me -2x squared. So I have my x cubed down here, my minus 2x squared down there. And then we're always going to be subtracting this line. All right. So you know the answer? Awesome. Hold on to it. It's too late for math. Oh, it's never too late for math. But some places it might be early. Some places might be just in time. So when I'm subtracting, I have a 0. Not a 0x squared, just a 0. It's gone. Because a negative, then we have a minus a negative. That makes this 2x into a positive. But then I'm going to bring down the next term, which is plus 4x. So now you're probably thinking, well, Aud, so what times x will give me 0? So can't we just say 0x? Or 0, sorry, not 0. Actually, I should put that x squared because it won't matter. Trust me, it won't matter. Because we all know eventually 0 times x gives me 0x squared. And you're probably like, wait, what? So pausing. Here we go. All right. Please start from the basic. Not a problem. Okay. So first we had to figure out what times x gives me x cubed. So we have x squared times x. Because remember, when you multiply, you add the exponents. So 2 plus 1 gives me the 3. That's where this x cubed came from. Now we're going to use this x squared and we're going to multiply by the -2. So x squared times -2 gives me -2x squared. Okay, are we feeling okay? How is -2 minus 2 equal to 0? Not a problem. So if I have a -2 and I'm subtracting a -2, when you minus a negative, it turns positive. Okay? So that means you have -2 plus 2. So you owe me $2, you pay me $2. Guess what? We're even Steven. You don't owe me anything. Okay? All right, never mind. Gotcha. So this gave me a 0x squared. So now we bring down the next term, which was this plus 4x. So then we have to do the process all over again. So what times x will give me 0x squared? Well, it's 0x. So 0x times x gives me 0x squared. So now I'm going to use this 0x and multiply it to -2. So 0 times -2, again, that will give me a 0x. Remember, zeros are placeholders. And we're just using this as a placeholder to help us get all the way to the whole dividend. So it's like long division with exponents. Exactly. That's exactly what we're doing. All right. Yes. And then Ray, keep change opposite. Yes. Unless you're hungry like me, keep change. Keep flip change. All right. So now let's subtract. These zeros, x squares, they're going to cancel out. But now I got 4x minus 0x. That gives me a 4x. Now I have that 4x. I bring down my negative 8. So we're going to do the process one more time. So what times x gives me 4x? Yes, OJ, that first term always cancels. Okay, the first term always cancel. All right, so I got some 1s, I got some 4s, I got some 4s. Okay, we changed the 1s to the 4s. Yes, so 4 times x gives me 4x. So it'll be a plus 4. Then I write down my 4x. Then I'm using that 4. 4 times the negative 2. That will give me negative 8. And I'm going to subtract. I always subtract. What's my result? Papa. Cancels completely. 0, 0, 0. Awesome. Yes. If they're exactly the same and you're subtracting, it's always going to give you a 0. So now we don't have a remainder. Okay? The best placeholder. So it's not going to be 16 because remember we have negative 8 minus a negative 8. When you minus a negative, remember it turns positive. So if you owe me $8 and then you paid me $8, we're even Steven. You do not owe me any money. All right, so we do not have a remainder. Okay, always state remainder with an R. Not necessarily, OJ. When you get into algebra, the remainder is not an R. Okay, you're adding it to your quotient. Oops, you're adding it to your quotient. But this time we don't have anything to add to the quotient. What do you think is my final answer? Yes, at the end of the quotient, yes. So if OJ, we had a remainder of 1, we're not putting an R. This is algebra. R is done. R was elementary. Once you get into algebra, if you had a remainder of 1, you will put plus 1 over the divisor, which is x minus 2. Yes. Yes. Okay. We took a college course. Okay. And we used R. Okay. Most people, especially advanced ones, do not use R. But if they decide to use R, they decide to use R. Okay. No, don't be confused. Because remember, what state are you in? If I don't mind being nosy. Okay, logged on to confusion. Hi, Gina. Welcome to confusion. It's okay. What would you put if the remainder was 2? So it's going to be 2 over your divisor. So you add the 2 over your divisor. All right. So if your divisor is x minus 2, so it'll be plus 2 over x minus 2. All right. Nope, no anxiety attacks here. Breathe. Breathe. Head between the knees. Hey, Audrey. Namesake. You're so patient. Yeah, no problem. I'll say. All right. So if I had a remainder, so let's say my answer here is supposed to be x squared minus or plus 4. Okay. If there was a divisor, say if there was a remainder of 2, you would add the 2, and your divisor is x minus 2. This is how you would write it out. Okay? So if you had a remainder, you put it over whatever your divisor is. So you're not going to put a 0 over x minus 2 because 0 divided by anything is 0. So 0 is a placeholder. We don't need to hold any placeholders. That's why our actual answer for this one is going to be x squared plus 4. Because that 0x, that's just a placeholder. So it's just kind of clogging things up. So we don't need it. We just need it to help us calculate and keep things moving. Once everything's moved on, then we'll just take what is supposed to be remaining. Okay, because that remainder is at the end and you're basically saying that it's a wrap, I cannot divide my last. You cannot divide my last what? Can you go over the first step one more time? That's the only thing I don't fully understand. I can do that. Okay, what is pi over the square? So we're not doing any pi's right now. Okay, now I should be able to sleep. Now you feel rested. You feel right with the world, okay? So for memo, this is what happens. You got your first term of your dividend, your first term of your divisor. Let me see if you can see it. All right. So then you think, what times x will give me x cubed? And if you recall, when you're multiplying, you're adding the exponents, right? So you need x squared times x to give me x cubed. You're always trying to find that very first step. All right. Hi, I just got here. Hello. Also, love graph paper. Thank you. All right. I actually designed this math notebook because I got so sick and tired of my students having notes all over the place. It was making me crazy. All right. It was definitely crazy. All right. So I'm not doing piecewise functions tonight because I'm not doing functions. We're just working on dividing, and I still need to do synthetic. Now, after we're done with synthetic, we got this. All right. So here we go. So synthetic division, just like different types of hair types. There's real hair and there's synthetic hair. Okay, synthetic hair is the one that's the quick, easy, you plop it on your head, you get it done, and then you hurry and take it out before it rains, right? You just basically have it right there. So synthetic what? Synthetic division. Let me tell you about it. So if I have our original divisor, so we have our dividend, sorry. So we have x cubed minus 2x squared plus 4x minus 8. All right. And we have our divisor, which was x minus 2. Now, what synthetic division does, it just basically takes the coefficients. Now, the coefficients are the numbers that's in front of the variables. So in front of that x cubed is a 1. In front of the x squared is a negative 2. In front of the x is a 4. And then the constant, a negative 8. Okay, do we all see where I'm getting these numbers from? Nope, Gina, you're breathing. Why are you stressed? Relax. Guess what, Gina? There's no test. This is not Squid Games. You're not going to be killed. You're not going to be hunted down. It's going to be all right. Breathe. And let it out. Yes. All right. So I got a few yeses. So if you take the coefficients, and what's going to happen, the divisor, you're always going to take as a key, you're going to take opposite what you see. Now, you see x minus 2. So that means I'm going to set inside a little box. And inside that little box is going to be the number that represents the divisor. Let me unzoom a little bit so we can see everything. So since I see a minus 2, inside this box, I'm going to put a positive 2. I always do opposite what I see. Are we all right? 1 is always in front of the variable, so 1x is equal to x. Yep, there's always, if you don't see a number, it's always assumed to be a 1. All right? So here is the process. The first number comes down. So the first number is a 1 in this case. So that's going to come down and kickstart the motion. This is what's happening. This number and this number in this row, we're always going to multiply. So 2 times 1 gives me what? Not to insult your intelligence, I know you know what it is, but just put it in there so I know that you're right there with me. Okay. Hey, Els. Perfection 2, 2, 2. Okay. Is it always opposite sign when you put in the box? Yes, it is, Memo. It's always opposite sign. Okay, and I'm going to show you one that has a plus sign after that. Good. So that answer of 2, I'm going to put an arrow. And I'm going to write the word, or I'm going to put the phrase NSH. That means your answer always goes underneath the next number. So I'm going to put the 2 here. What we're going to do with these two answers, we're going to add them together. So you multiply, put the answer underneath the next term, and then we're going to add together. So what's negative 2 plus 2? AJ, thank you. We got our 0. Are we okay? Yes. Good, Lisa. Gina. See, Gina, you're all right. Okay. Absolutely. Yay. All right. Good. So now we're going to do the process again. Remember, this row we're going to multiply by what's inside the box. So 2 times 0 will give me what? Gina, there you go, girl. All right, AJ, Ebony, yes, yes, we got the 0. So we're putting the 0 underneath the next term. Now we're going to add these two. So 4 plus 0 gives me what? Sam is a mind reader. Good job, Sam. There you go, Gina. There you go. We got our 4. All right. So I'm going to multiply the 2 and the 4. And that gives me what? Yes, Sam. Yes, Gina. Yes, Lisa. Memo. Good. Nickel. Tired. Yes. Perfect. Yes. Hold on. Hold on. Why am I seeing a 46 and then seeing a negative 4? Okay. Are we messing with my head? Because we're not doing that. 2 times 4. That gives me 8. Okay, let's keep it simple. We're multiplying these two numbers. Okay, all right. I just want to make sure. All right, good. Now, add these two numbers up. Everyone's got a step ahead of me, which is awesome. That means negative 8 plus 8 will give me 0. All right. So, we don't have anything else. What we have, we're going to focus on this last line right here, because this is basically our answer. So, if you recall, the 1 came from the x cubed. The negative 2 came from the x squared. The 4 came from the x, and the negative 8 was our constant because it doesn't have a variable next to it. Your answer choice is always going to be 1 degree less. So we got 1 degree less, or 1 exponent less. With that being said, that means this is going to be an x squared. This is going to be an x. This is going to be a constant. So that means this is going to be our remainder. Right? Good. So if we rewrite this, put the coefficients in front of each of our terms. So that means we have 1x squared. 0x, remember 0 is a placeholder, so we don't need to write that down, plus 4. And we don't have a remainder, and we don't need to write that down because 0 is a placeholder. That looks familiar. Because isn't that the same thing that we got up here? But with less torture? Yes. Good, right? So I know a lot of us from the very beginning were like, why don't we just use synthetic division? Why don't we use just synthetic division? Why don't we use synthetic? Why don't we use synthetic? All right. Because there are some people that love to torture students and continue on using long division. But here is the trick. Synthetic division only works when your divisor has just an x in front. Remember this problem that we did back here? It has a 3x. We can't do synthetic division when there's a 3 or a number in front of that x. You're going to have to do long division. So if you look on the test and you notice they have x minus 1, you can do synthetic. But if you notice on that test, it says 3x or negative 5x or 1/2 x, guess what? You have to do long division. That's the difference. So why do they call it synthetic? Because we're not doing this whole lovely process right here step by step. We're only taking the coefficients, okay? And we're taking its divisor by its opposite signage. So we're not doing the whole step by step. Sorry. We're not doing that whole step by step. So that's why they call it synthetic. It's kind of fake-ish. Okay, air quotes. Yes, the divisor has to be linear, so it can't be a square either, and it can't be a cube. But it cannot have a number in front of the x. All right? Oh my God, synthetic division. Yes. Can you do another one like the top? Like long division? Or like synthetic? Because we only did one of synthetic. Like the top. Yes. Guess what? Like the top? Long division or synthetic? Long division. Thank you. Sure, I can do one. So let me put that on. And with the number in front, definitely. All right, so let me put it on a separate sheet of paper because I'm running out of room. So, let me, I don't like those. Don't want to do those, but I can do, I don't think I did this one before. Hold on, let me double check because I hate doing repeats. Okay, nope, got it. All right, so we have, my divisor is 4x minus 1. Let's have fun with this. So I'm going to do this with long division. And for those that want to try synthetic division, let's see if you get the same exact answer. I know, there's me being a teacher at 10:07 in the morning, at night. Once a teacher, always a teacher. All right, actually, let me move this to the side. So I'm going to do long division on this sheet of paper. But if you guys are okay with synthetic, do the synthetic and then we'll compare our answers. Okay? So we have 4x minus 1. That's your divisor. Your dividend is 8x squared plus 2x plus 3. So let me zoom in just a tad. All right, so we got to think. Look at your first terms. What number times 4x will give me 8x squared? I know. I'm on East Coast too, so trust me. And I've been tutoring since 8 o'clock this morning. Hi, how you doing? Yes, good. So that means if it's 2x, I'm putting the 2x in x's. Always line up with x's. Do not line it with the x squared, because then you get lost in the sauce later on when it's time for you to write your final answer. So then you rewrite your 8x squared underneath, because 2x times 4x gave us our 8x squared. Now, take this 2x and multiply by this negative 1. That gives you a negative 2x. Okay, how are we doing? Okay, so I see the 2x's. So 2x times negative 1 gave me negative 2x. I think I have the answer. I'm catching on pretty quick. All right, awesome. So now we're going to subtract this line. So 8x squared minus 8x squared, these 8x squares cancel out, including the x squares. Lost in the sauce already? Okay, it's all right, Roxy. We're going to take it step by step. Okay. So let's see if we can get this subtraction here. So we have 2 minus negative 2. So if I put it over here, 2 minus negative 2. What do I get for an answer? Oh, so you got 2 plus 2, which is right. And that does give you 4. So that means underneath here, you got 4x. So once we solved, now we need to bring down the next term. So the next term is plus 3. So now we're going to do the process all over again. So we got to think, what number times 4x gives me 4x? One. Good. Positive 1. So we got plus 1 is coming up here because 1 times 4x gives me 4x. Then we're going to use this 1 multiplied to the negative 1. So 1 times negative 1 gives me negative 1. Okay, good. So we're subtracting this line. So the first term, if you haven't figured it out yet, y'all, the first term always cancels out. Okay, it always cancels out. So now we have 3 minus a negative 1. What does 3 minus negative 1 give me? Good, Ebony, it does cancel out that first term. So 3 minus negative 1, tired of life? Aw, hope that could change. Yes, I'm seeing my 4s, seeing my 4s, seeing my 4s. Good. All right, so now we don't have anything else to come down. Okay, not minus 4, just a positive 4. Because when you minus a negative, it turns positive. This is a math class today. Nice. So, since this 4, and there's nothing else to bring down, this 4 is going to be my what? Yes, so that is your remainder. Yes, your R, your remainder. I know a lot of people can't give up the R. Over 10 years ago, hey, I know. But it's all coming back. So this is your remainder. Now, as I was saying to, what was his name? OJ. As I was saying to him, when we're in algebra, we don't write the capital R anymore. Okay? Yes, Lisa. Love that. You write your remainder. You're adding it on. So you have your 4 over whatever your divisor is, which is 4x minus 1. So this is your answer, or another name, your quotient. Okay, that's what your answer is called. Yes. Okay. What is this type of problem called? This is dividing polynomials. Okay, dividing polynomials. Thank you so much for the following, the likes and the loves and the appreciation. I greatly appreciate that. Oh, wow, 14K? Look at us. All right, all this based off of math. Now, I want to go over it. Not a problem. How you feeling, Rasta? You're okay? Okay, I have to teach this on Tuesday. I know. And trust me, patience. Summer, you're not being rude, being curious. Go ahead. When would this be used in life? Well, if you have to make decisions. Now, decision making, no one's not going to actually, and you're not being rude, because this is the question that a lot of students ask. And just because it's written out in this, what is it called? In equation form, you can tell I've been doing math all day. In the equation form, you're like, when do we use this in equation form? But because of these equations, these little tidbits, it helps us with making decisions. So should I do this? Should I do that? Should I process? Should I add? Should I subtract? Am I going, like I mentioned earlier, like if I'm traveling to go somewhere and it normally takes 20 minutes, but it's going to be high traffic. High traffic usually takes things about an additional 20 minutes. So what time should I leave? A lot of those things are based within these type of problems. So it's just really helping students to think outside the box. Now, the thing I like to say is when I was a classroom teacher, because trust me, I know I'm not walking around saying, let me see if I could take the derivative of a square root. No one's saying that. But here's my thing. I don't know who is thinking about being an engineer. I don't know who's thinking about being a plumber. I don't know what these kids want to do in their next steps of life. But this is the thing. I want to make sure that they have seen this before and they can adjust to it and try to think and try to apply as best they can. I rather say, hey, I'm going to show you as much math as I can possible, instead of you going in a situation like, what the hell is this? I don't want you to ever feel to the point that you are going to be in a disadvantage because I didn't teach you anything. You know what I'm saying? So that's kind of like what I'm trying to do. Can you do another one and go over it? I entered late. Okay, I'm not even in school anymore, but I love this. All right, cool. This is used in engineering. Yes. They take it all the way to like Calc 3 sometimes. Coding, definitely. Who said coding? Yep, Pamela, coding. Have you ever taught pre-calculus? Yes, I have. I'm starting to help students with their AP pre-calc. That's very interesting. I need to study for the PERT test. I'm not great at math. You're saying you're not great at math because we just haven't had the right exposure. I'm going to have to correct you on that. Cool. I never thought of that way. Always thought it was measuring mostly. True. And like, even think about the phones and the internet. All that stuff is math. Doing logic, lawyers, doctors, all that is math. So math is like its own entity. Now, let me, please, another problem. I'm learning it right now in 10th grade. Let's see. Let's go with, now I'm going to give you a problem that you guys are going to do it. And you can do it either with synthetic or long division. So I'm going to give you that choice. So I have my x plus 5 as my divisor. I have my 5x squared plus 2x plus 3. Let me make sure I'm not repeating any problems, because that is the absolute worst thing you can do. All right. I'm about to do composite functions. Oh yeah, wish you luck. You got that. Always remember to work from the inside out. And I didn't learn it, suffering from it now. That's all right, because right now, synthetic division, after we do this one, I'm going to show you the answer in synthetic. There's a formula for that. Is there a formula for this? How to start it off? You got to think, what number times x will give me 5x squared? And you're going to put that answer, I'm going to put it in a highlighted spot. And you're going to put that right here in this highlighted spot. And you're going to put that answer, I'm going to put it in a highlighted spot. And you're going to put that right here in this highlighted spot. Must didn't realize what time it was. I'm over here just having fun. Just putting everything out there. Okay. Excellent job on your 100. It paused. Yes, because my phone's about to die. Because I was only expecting to go till about 10, but I think this with the synthetic way, I'm going to have to stop. Because as I said before, I've been doing this since 8 o'clock this morning. I'm a little tired. Like, you're catching me at loopy Audrey. So that is definitely going to be entertainment in itself. All right. So a lot of people are saying 5x goes right here. So that means in this slot, 5x times x gives me 5x squared. Then we're going to use this 5x, and now we're going to multiply it by the 5. So 5x times 5 gives me 25x. And then you always subtract this line. Yeah, tonight is not fractions. Yeah. Most of those fractions we're going to do, I usually do in my morning sessions. What do I get for a result when I subtract 2x minus 25x? What's happening? Okay. Yep, because these cancel out. So 2 minus 25 gives me a negative 23x. Good. So make sure it's negative because it's 2 minus 25. So I have $2. I want to buy something that's $25. Yeah, I'm short $23, right? All right. Okay. Or can you say, you can say that. I think the second one is a little bit better. So now, bring down the plus 3. So what times x gives me negative 23x? So what times x gives me a negative 23x? Okay. There we go. So Kyle, we got negative 23. Okay, so if you're still a little lost, just take a look. Because negative 23 times x gives us a negative 23x. And just like when Summer mentioned, Summer, check your signs. Check your signs. Okay, what is the divisor? So the divisor is x plus 5. Can you zoom out a little? Sure. Oh, my fault. So sorry. Okay. All right. Got it? Also, there you go, Summer. All right. So when we had to figure out 5x times x gave us 5x squared. Use that 5x times the 5 gave us the 25. Once we subtract, 2 minus 25 gave us negative 23. Then we had to think, what times x gives me negative 23x? Negative 23 times x gave me negative 23x. But then we have a negative 23 times 5, so that gave us a negative 115. When we subtract, So when we subtract, these cancel out. So now you have 3 minus a negative 115. So when you have 3 minus a negative 115, when you minus a negative, they turn positive. So it's actually saying 3 plus 115, which gives me 118. Okay, so 3 minus a negative 115. When you minus a negative, it turns positive. Okay, perfection. So it's going to turn positive. So when it turns positive, that means you're just adding. So 3 plus 115 gives us 118. Good. So now 118, we don't have anything else to come on down. So that means this 118 is my remainder. So I'm going to add my remainder, which is 118, and we always place it over the divisor, which is x plus 5. All right. Please never stop doing these lives. God willing, I will be here. I'm learning this in algebra right now. Good. Okay, nice. So now you're getting a little extra practice with it. We're trying to build your confidence with it so you can take it and run it on point. Writing on point, yes. All right. Okay. If I did this with the original as synthetic, I'm going to change my colors of my pen. Okay. If I had it as synthetic, let me show you. Here's the original. I can't really use that. I'm going to use this one. So this is my original equation here, or dividend. This is my divisor. So what you're doing with the dividend, you have x to the second power, you have your x, you have your constant. We're going to just write the coefficients and the constants down. So we have our 5, we have a 2, and we have a 3. Okay? The 5 is representing the x squares. The 2 is representing the x, and the 3 is representing the constant. Now, what goes inside this box? We're going to look at the divisor. So the divisor says x plus 5. You want to do what's the opposite. So the opposite of plus is going to be minus. All right, so yes, we're doing synthetic division. So here's what's happening. This very first term always comes completely down. Then we're going to take our divisor and our next number, and we're going to multiply it. So what's negative 15? Negative 15. Woo, you're starting to see numbers now. What's negative 5 times 5? Okay, good perfection, negative 25. Now, negative 25, Batty, yes. Multiplying, Holly. Make sure we're multiplying. So negative 5 times 5. Good, life's too short, negative 25. Now, that answer that goes under the next term. So negative 25. So what we're going to do is add these two numbers together. So 2 plus negative 25. What would that give me? Okay, Ebony, trust me. And that's why I teach both. That's why I teach both. Good. We got negative 23. Good. So now we're going to repeat the process again. Multiply negative 23 with negative 5. So what's negative 23 times negative 5? So we got our positive 115. Good. That answer goes underneath the next term. So now, one more time, we're going to add these two terms together, which gives us our 118. Okay, so now we have nothing else left to bring down or to combine. Basically, what we see before us at this part right here, this is basically our answer. But the only thing is, you always go one less the original degree. So if it's an x squared, that means this is going to be an x value. If this is an x, that means this is going to be a constant. And if this was a constant, that means this is going to be your remainder. So if you want to put it in that standardized form, your answer is looking like 5x minus 23, and we have our remainder of 118 over the original divisor, not the -5, but the original divisor, which is x plus 5. Okay? So you have a choice. You have choice. So is this college algebra? Yes, it's a combination of college algebra, algebra 1, if it's honors, it's like second semester, and algebra 2. Because most algebra 2 teachers are teaching dividing polynomials. Okay, you're welcome. Love it? You like it? Guys, my IQ just went up. Woohoo! Love it. All right. Well, right now, I am done. I had enough. I'm burnt to a crisp. And then, of course, I have to tutor tomorrow. Not a problem. Where did you get the 115 from? If I multiplied -5 times -23. A negative times a negative gives me a positive. 5 times 23 gives me 115. All right. So you always multiply and then put your answer underneath the next term. Okay. You're welcome. Okay. Need to start from scratch? That's fine. And say, I'll be back for the fractions. Not a problem. What state are you in? I'm in Maryland. Okay. Thank you. You're so welcome. Thank you so much for the likes, guys. I really greatly appreciate this. I know as I mentioned, I actually designed the original notebook that we were using. So if you know of anyone that is looking a way to organize their notes a little bit, because trust me, we all know how crazy your math notes are probably looking, or you're so used to just getting packets from your teachers, and most of you guys are not looking at your packets. You're not. Let's be real. All right. So for me, I have a section where you can put formulas, a section where you can put your steps, and then a section where you can put the sample of your work. I like to put this, especially for like homeschool parents, also for teachers, that if you're looking at how are the kids feeling before, during, and after the lesson. I know a lot of administration, especially when they do their observations, they're always asking, how do you know the kids are learning? I know, these questions make you crazy, right? So some people say, well, I do a thumbs up and a thumbs down. Students don't like that because they don't want to seem like, oh, I'm dumb, but you know what? I'm not going to put my thumbs down. I'm going to be like, yeah, I totally get this. And deep down inside, you're like, no. All right. So they can, just on the slide tip, they can just easily circle. They're like, okay, how was I feeling before this? I was feeling a little meh. All right. But how am I doing during it? To see you guys working hard and getting this answer. And how am I feeling now? I'm tired, but I am so joyful because look at you guys. It's Friday night and we're here. There's 50 people in here and we're doing math. And I have almost 2,000 likes and hearts. Oh my goodness. And we're doing synthetic. 1,000 likes and hearts. Oh my goodness. And we're doing synthetic. 1,000 likes and hearts. Oh my goodness. And we're doing synthetic. Sorry. All right, back. All right. Okay, we're back. We're live. All right. My phone's about to die. So anyway, I know, and of course, my charging cord is on the other side of the room. This is what happens when you have cats and they just like to play with stuff. There's a purpose. There's a reason why they're here. But as I was saying, so we have like multiplying polynomials. We were working on that last night, solving multi-steps. So all these things, one-step equations I was working on with some of the students, breaking down radicals, taking a look at adding, subtracting radicals, factoring. Notice how we can actually break a lot of these concepts down. And it's not just algebra. Here's us using synthetic I was working on before it. Okay, solving and graphing linear equations. All right, same in standard form. We were doing slope-intercept form. I also have, where's some of my geometry stuff? Here we go. So I take a little bit of stuff from the papers from geometry, and I just simply like use both sides, because one side, you might get a teacher that says, hey, I really want you to have this paper in your notes. You can tape it inside this book, and then on the other side, summarize what's on that paper. So if you ever get like an open notes quiz and all of a sudden you can just pop right into here and be like, oh, okay, this is how the examples. I can look at the formulas so much quicker. Now, when I was looking at breaking down those radicals, breaking down those square roots, the hardest part is trying to figure out those perfect prime combinations to break it down. So it's not just a notebook. It's also, it has a factor sheet. Okay, so if I want to break down the square root of 68, I can come, let me see if I can, zoom up. So if I want to go to 68, I can go to 68 and say, all right, I got 1 and 68, 2 and 34, and 4 and 17. Boom. 4 and 17, that's that perfect prime combination. So then you can break down the square root of 68 so much quicker, because the square root of 4, that's your perfect, which gives you 2, and the square root of 17 is prime. You can't break that down any further, right? So I need help on all this in your book. Yes. Okay. What's the book's name, please? So this one is just a notebook. It's not a workbook, but I have a lot of resources that can be helpful. If you struggle with word problems, I have a sheet for most popular words that's used in word problems. I also have the rules of integers in here. Then we have the order of operations. Okay, we kind of worked a little bit on these two laws of product and quotient. When we multiply, we add the exponents. When we divide, we subtract the exponents. So we actually did some stuff on here. Got stuff for linear. For my people that's in geometry and they're looking at volume and surface area, we got the formulas right here for you guys, as well as once we get into SOHCAHTOA, a little bit of trig. We got to have these trig identities. And then for my Algebra 2 people, if you haven't touched on it just yet, or pre-calculus, get ready for the unit circle, baby, because it is coming. Yes, trig. Are you doing daily lives practicing? Yes, except for on the weekends. Right now, I'm basically here at 1 o'clock Mondays through Fridays, Eastern Standard Time. And then Mondays through Thursday is till 8:30. But I had a cancellation tonight, so I just decided to come on at 8:30. And then here I am. Look, I'm with you guys. This is all wonderful. Okay? I need them factors and squares. Oh, yeah. Because a lot of you guys, and it's not your fault, you guys just don't know how to use the multiplication table because you weren't taught, all right? As soon as the calculators entered into the game, a lot of teachers just forgot to use the whole cadence of how to multiply, and they just did all division off in the calculator. So it's not your fault. It's not your fault. So we just have to learn to struggle, not to struggle, but to kind of work on it step by step. Okay, yes. So I major in that and minor in math, and this brings back so many long nights. Yes. And it's okay. But guess what? It's coming back, right? And then, of course, I like to put in brain breaks because we all need a brain break. I know I need one right now. So some puzzles to kind of help you refocus. Maybe even just a random color page just for you to just randomly get your color pens and just kind of go at it for a little bit. If you like pixel art and you want to draw some pixel art, you have fun with it. If you like to sketch and draw things, it gives you a place just for you to be creative. Because remember, all learners do not have to be like, let's do math, this is it. Okay? You can do math and still be able to just relax. Best thing about this book is once you fill it up, you could probably resell it to whoever's taking the class the following year. I'm always thinking about different ways to make a little bit of extra cashola, right? So where can you get this book? You can get it off of Amazon. I have 3 different covers. If you want, you can go to my website, which is the link in my bio. If you just click on my profile picture, it should take you to it. And then I also have courses if anyone is thinking about taking their GED or they're thinking about going to the military and they need the ASVAT. All right. There is practice problems and courses in there. But if you don't want to buy the whole entire book and you want to sample it for yourself, you can get some digital downloads. That's available as well. But trust me, you want to have a book so you can keep everything in here. You get 100 pages of each of the Cornell inspired side as well as the graphic side. I think my next book, I might just keep it all as dots because I really like how we can get these nice, clean graphs when we do plotting of points. Okay, compared to the grids, it's all right. I mean, but I like the dot one. That's just me. All right. So that is it for me. I watch TikTok videos after the physics test. Hey, I know sometimes you just need to chill, right? Like Sokotoa, okay, you're helping me understand math so much better. Thank you. Not a problem, Kathy. I'm here. All right. So if you ever, and I'm playing around with the idea, if you are currently taking, say, college classes, because I know those college classes go so quickly, I'm thinking about having like a study group because there's some people, they just need like a couple pointers here and there. And I'm thinking about starting a study group, possibly next weekend. So I'm going to put out a poll just to see if it's something worthwhile. I am so willing to do it. I'm completely down with helping people. I might have one in the morning and one in the afternoon because I know time zones is a little off. But if you want me to do one-to-one, you can definitely hire me. I definitely have a couple slots left that I can do that. I'm one of those type of people. I have students all over the place, so time zone really doesn't matter anymore. It used to in the beginning. Now I'm like, I'm over it. Like I'm on the East Coast and now I'm getting people in Washington State and California and Texas and Alaska. And yeah, it's all kinds of cray, right? So you're like, all right, why not? Let's just go. Okay, do you teach high school math? I used to. I was a classroom teacher. I left about 5 years ago. I'm studying to be a pilot. Oh, awesome. I know people that want to do that too. I really need your help. Okay, I will help as best I can. I can tell you right here and now, statistics is not my jam. Can I do it? Yes. But I'm going to tell you, I'm going to have to do a lot of research, a lot of up and down, and that's just not a good flow. But I got a guy. If you're doing AP calculus, I got a guy that is doing awesome, and he is like my direct line for that. So if you ever need that, I got you. I don't see the link for Amazon to purchase the book. If you see where it says books on Amazon, click on the Amazon picture. So if you just see the word Amazon, click on Amazon. I know. I think I got to make that a little bit clearer. That's something on my to-do list for this weekend. I retired almost 3 years ago as a high school math teacher. Yes. I'm telling you, Pamela, I'm telling you. It's just things have changed since COVID. Completely changed. So right now I'm done with the teaching. I'm just doing a little chit chat just so I can calm myself down. Because usually you get hyped up when you meet people and you're talking about things. So if you want to sign off, you can go ahead. I will see you guys on Monday. But if you have any questions, please do not hesitate to DM me. You can definitely reach me either on my website, or you can just DM or message or comment on any of my posts, because that's the one thing I like to do is my post on here, as well as if you want to go to YouTube, that's another one. I am really revamping my ACG math tutoring one with a lot of samples on there as well. So if you want to subscribe, that would be awesome. But if you just want to take a look at some of those videos, that might help you as well. Okay. I occasionally sub, and things are way different, completely different. Do you allow teachers to make copies of your digital workbook for students' use? I'm fine with it. I'm over life. Like, I'm not like, oh, my precious. This is my precious information. If it helps kids, because my copyright's on there, just have fun with it. Make copies. Do what you gotta do, boo-boo. You know? I'd rather the kids sample it and they're like, ooh, this is really cool. It'll be really cool if this was in a book, because I don't want papers all over the place. That's what happens when you put it in binders and stuff. But if they just want to try it out and then they contact me and say, hey, Audrey, I love this book. I really want all my kids to do it. I mean, I might be able to do a discount for a whole classroom. I can do that. You know why? Because I'm Audrey. I mean, I made it, so I guess I can do anything I want with it. Hell, Amazon is taking like a big chunk out of it. So, you know, if that is something to help kids out and to really get that whole transformation, I'll do it. You just gotta have to pay for the shipping and handling, though. That's the one thing that kills people. Let me start a donor's choice for that. Oh, that'll be cool. Hey, knock stuff out. Okay, I must be overlooking something. I only see Instagram, YouTube, Lemon 8, and the link to tutor site. Yes. Oh, click the link because it's inside my tutor site. Yeah. Like my Amazon, I can't just do an Amazon link. YouTube, I don't think YouTube, not YouTube. I'm so sorry. TikTok. I forgot where I was for 5 seconds. I don't think TikTok allows us to do Amazon. If so, I think I tried and it just like, no. And I don't even know why I have Lemonade anymore, because they got rid of that. All right. Pamela, have an awesome night. Thank you so much for stopping in. I greatly appreciate it. All right. I'm just going to hang out for just a couple minutes more to make sure you guys have everything you need to close up. Because I don't want to just be like, bye. And then you're like, I got questions. So I'm going to hang out for like probably 2 minutes more. Okay. All right. Have a lovely night, guys. Stay safe, please. Because everybody's losing their blessed minds. Stay safe. Keep your mind together. And remember, you are awesome. You did math on a Friday night willingly. And you did it successfully. You guys are amazing. I love it. Don't let anyone tell you anything different. You guys are amazing. Oh, thanks for the hearts. Okay. Beautifully defined. If you ever get stuck or if you have any questions, you can, what's it called? Friend me. There we go. And then, I think my Solo 2 is still up there. If my Solo 2 account is still up there, you can contact me through there or just see me Monday. You can also look me up on Google. You can Google me. You know, you'll probably see a lot of my basketball stuff too as well. But you can Google me. Fun fact, I used to be a professional basketball player. I'm inducted into 2 Hall of Fames. Those were the days, and that's why my knees are bad. All right, cool. All right, so let me know. See if they like it. If they like it, great. And then let me know if we need to do anything for your class. I'm more than willing to do that, okay? All right, ladies and gentlemen, I am going to wrap up and pass out. So I will definitely see you guys on Monday. And if you ever need someone, if you want to learn something new, like learning math through the abacus, my friend is Lynette is always on here. We try to support each other as best we can. She's really good with it. If you have youngsters that really need to understand what numbers are and how to count, how to add, subtract, multiply, and divide by using the abacus, tune in to her. I will be on her site on Sunday. I think she usually gets here like 11 a.m. Eastern Standard Time. All right. Have a good night. Love you guys.